Microsoft just dropped something that might completely flip the real-time voice AI race. And honestly, nobody was expecting this timing. We're talking about VibeVoice-Realtime 0.5b, a text-to-speech model that generates initial audible speech in roughly 300 milliseconds, supports streaming text input, and handles up to 10 minutes of continuous generation without breaking rhythm. And the crazy part is that this landed on December 3rd, 2025 with zero fanfare. No launch event, just a quiet GitHub release and a moral card on HuggingFace. While everyone's been watching ElevenLabs push latency down to 75 milliseconds with the Flash v2.5 and OpenAI sitting at reported latency around 200 milliseconds with their TTS system, Microsoft silently built something that sits right in that competitive sweet spot at 300 milliseconds, but runs entirely open source under an MIT license with only 0.5 billion parameters. So let's talk about it. Alright, so the first thing that caught people off guard was the release strategy itself. Microsoft already has VibeVoice 1.5b and VibeVoice 7b, the multi-speaker long-form variants that can generate up to 90 minutes of conversational audio with 4 distinct speakers. Those models launched in August 2024 and got decent attention from the research community for their ability to handle podcasts and audiobooks without stitching. But this real-time variant is completely different. It strips out the multi-speaker complexity, removes the semantic tokenizer entirely, and focuses purely on speed and single-speaker streaming. And when you look at the architecture, it becomes clear why Microsoft went this direction. The model uses an interleaved windowed design where incoming text chunks get encoded incrementally, while in parallel, the diffusion-based acoustic latent generation continues from prior context. That overlap between text encoding and acoustic decoding is what lets the system hit that 300 millisecond first audio latency mark on suitable hardware. And to be clear, that's not when you hear it through a network. That's the model's internal generation time. Network latency adds more delay depending on your setup, but the core model itself produces the first chunk in about 300 milliseconds. Here is the thing. The entire VibeVoice family is built around continuous speech tokenizers operating at an ultra-low frame rate of 7.5 Hz. That's aggressive compression. Most speech tokenizers run at much higher rates, but VibeVoice cuts the signal bandwidth down to achieve better long sequence efficiency. The acoustic tokenizer they are using is based on a Sigma VAE variant from LatenLM with a major symmetric encoder-decoder structure featuring 7 stages of modified transformer block. It performs 3200 times downsampling from 24 kHz audio, which is why the decoder component alone has about 340 million parameters. Then on top of that tokenizer sits a lightweight diffusion head with just 4 layers and roughly 40 million parameters. That diffusion head is conditioned directly on headed states from Qwen 2.5 0.5b, which is the base language model handling text encoding and contextual flow. The diffusion head predicts acoustic VAE features using a denoising diffusion probabilistic models processed with classifier-free guidance and DPM solver samplers. The full stack including the LLM, acoustic decoder and diffusion head lands at around 1 billion total parameters, which is critical for deployment sizing because it means the model fits comfortably on a single GPU. For inference, it typically needs under 2 GB of VRAM, making it practical for edge devices, laptops, and real-time agent workflows. Now let's talk about the numbers because this is where things get competitive. On LibriSpeech Test Clean, which is the standard zero-shot TTS benchmark, VibeVoice-Realtime 0.5b hit a 2% world error rate with a speaker similarity score of 0.695. For comparison, Vol E2 reached 2.40% WER with 0.643 similarity, and VoiceBox got 1.90% world error rate with 0.662 similarity. So VibeVoice sits right in the middle on accuracy but delivered stronger speaker similarity than Vol E2 and stays competitive with VoiceBox despite being designed for streaming rather than offline synthesis. On Seed Test N, another short utterance benchmark, it scored 2.05 world error rate and 0.633 speaker similarity. Spark TTS came in slightly better at 1.98% world error rate but lower similarity at 0.584, while Seed TTS reached 2.25% world error rate and the highest reported similarity at 0.762. The research team noted that the real-time model is optimized for long-term robustness rather than short sentence performance. So these metrics are informative, but not the primary target. What matters more is that the model can sustain generation for extended durations. With an 8K token context window, VibeVoice Real-Time can output roughly 10 minutes of continuous speech without resets. That's enough for live reading, AI radio formats, voice agent dialogues, support calls, and monitoring dashboards. And honestly, when you compare this to the broader TTS landscape, the positioning becomes really interesting. ElevenLabs achieves 75 milliseconds with Flash V 2.5 model and 150 milliseconds with standard models. But their pricing runs on monthly subscriptions starting at $5 for 30,000 characters and scaling up to $330 for 2 million characters. OpenAI keeps it simple with pay as you go at $15 per million characters for regular TTS and $30 per million for HD, with reported latency around 200 milliseconds. VibeVoice Realtime 0.5b is completely free under the MIT license, runs locally, and hits 300 milliseconds. That's not the absolute fastest, but it's fast enough for real-time conversational experiences where 1 to 3 second delays would kill the interaction. And because it's open source, developers can deploy it without recurring API cost, without vendor lock-in, and without worrying about rate limits or user tiers. The trade-off is that you are running your own infrastructure, but for anyone building voice agents, live narration systems, or spoken LLM interfaces, that trade-off makes sense. The architecture itself is what makes this possible. Unlike the full multi-speaker VibeVoice variants that use both semantic and acoustic tokenizers, the real-time model removes the semantic tokenizer entirely and relies solely on that efficient acoustic tokenizer running at 7.5 Hz. By stripping out the semantic layer, the model eliminates computational overhead and reduces the number of steps per second of audio compared to higher frame rate tokenizers. Training happened in 2 stages. First, the encoder tokenizer was pre-trained separately. Then the tokenizer got frozen, and the team trained the LLM along with the diffusion head using curriculum learning on sequence length, increasing from roughly 4,000 to 8,192 tokens. This kept the tokenizer stable while the LLM and diffusion head learned to map from text tokens to acoustic tokens across long context. And the recommended setup is to run a VibeVoice Realtime 0.5b next to a conversational LLM. The LLM streams tokens during generation. These text chunks feed directly into the VibeVoice server, which synthesizes audio in parallel and streams it back to the client. For many systems, this looks like a small microservice. The TTS process has a fixed 8,000 context and about 10 minutes of audio budget per request, which fits typical agent workflows. Now, in terms of limitations, there are a few things worth mentioning. This real-time variant supports only a single speaker. If you need multi-speaker conversational speech generation, you have to use the other VibeVoice models like VibeVoice 1.5b or VibeVoice 7b. The model is currently intended for English speech only. Non-English text produces unpredictable results and is officially unsupported. To mitigate deepfake risks and ensure low latency for the first speech chunk, voice prompts are provided in an embedded format. The model ships with a few voice presets like Carter, Davis, Emma, Frank, Grace, Mike for English, and Samuel for Indian English. Voice cloning isn't supported yet, though the community is already working on it. Microsoft mentioned they will be expanding the range of available speakers, but for now, customization is limited. The model is also speech only. It doesn't generate background ambience, music, or sound effects, so it's better suited for voice interfaces, assistant-style podcast, and programmatic narration rather than media production. And Microsoft explicitly states they don't recommend using VibeVoice in commercial or real-world applications without further testing and deployment. This model is intended for research and deployment purposes only. But here is what really matters. The AI research community has been calling this a dark horse model and one of the lowest latency, most human-like open-source text-to-speech models available today. Experts are commending its accessibility, resource efficiency, and potential to set a new standard for local AI voice applications. Some community concerns are popping up around its English-centric focus and the built-in safety features that limit voice customization. But overall, the reception has been extremely positive. Independent evaluations show the model performance compatibility on standard zero-shot TTS benchmarks while maintaining a balance between intelligibility and voice consistency despite its smaller size and real-time constraints. The timing is also fascinating because this release puts direct pressure on tech giants like Google with Cloud text-to-speech, Amazon with Polly, and Apple with Siri. Microsoft's strategic decision to open source such advanced real-time TTS technology under an MIT license forces these companies to either enhance their own free or low-cost offering or clearly differentiate their pro-priority services through superior multilingual support, broader voice customization, or deeper ecosystem integration. And for specialized AI labs like ElevenLabs, this creates a significant competitive tension. While ElevenLabs offers sophisticated features and high-quality expressive voice synthesis, VibeVoice free, robust long-term generation could threaten premium subscription models, especially as the open-source community further refines and expands VibeVoice capabilities. Then there is the broader context with the original VibeVoice release. In August 2024, Microsoft open-sourced the 1.5B and 7B variants, and those models could synthesize speech up to 90 minutes long with up to 4 distinct speakers in a 64K context window. But shortly after release, Microsoft discovered instances where the tool was used in ways inconsistent with the stated intent. Since responsible use of AI is one of Microsoft's guiding principles, they disabled the repo until they were confident that out-of-scope use was no longer possible. The community responded by creating backup forks, and now there is an active unofficial Discord community sharing samples, asking questions, and discussing fine-tuning. Microsoft has since restored the official repo without code but with a statement about responsible AI use. And on December 3rd, 2025, they open sourced the real-time variant with full code and model weights. So the ecosystem is alive, the community is engaged, and developers are already integrating it into local AI assistants, reading apps, and real-time simultaneous interruption tools. In the future, this might become the standard for local AI voice systems. In fairness, there are still unknowns. We don't have extensive real-world data yet on how the model performs under heavy load with noisy input text or in challenging acoustic conditions. The model inherits any biases, errors, or omissions from its base model, which is Qwen 2.5 0.5b, and there is the obvious concern about defects and disinformation. High-quality synthetic speech can be misused to create convincing fake audio content for impressions, fraud, or spreading disinformation. Users are expected to use the generated content lawfully and disclose AI-generated content when sharing it. But these limitations are standard across the entire TTS field. What's different here is that Microsoft is pushing the boundaries of what's possible with lightweight, streaming-focused architectures while keeping everything open source and accessible. That's where we will wrap it up. One thing I'm curious about now is how this changes the calculus for campaigns building voice agents. If you can run a sub 300 millisecond TTS model locally on edge devices without paying API fees, that fundamentally shifts the economics of conversational AI. Drop your thoughts below. Make sure you are subscribed, hit that like button, and I will see you in the next one.